Okay, we're on topic 8.4 and we're going to work with more proofs using algebraic properties. You might want to refer back to the properties in section 8.3, transitive, reflexive, symmetric, addition, subtraction, multiplication, and division properties. You've been working with these throughout algebra. Now we're going to talk about them and get you ready for some geometry proofs. We're going to start by using some algebra. Look at example 1. X equals 3 and y equals 3. Those are two different givens, so if you notice in the chart we're using two lines to show x equals 3 as a given and y equals 3 as a given. You can kind of think of as a proof as a way to explain math in a table form, or to help someone understand why things work they do, especially in algebra in a step-by-step equation. The reason the transitive property is your reason for your proof that x equals y is because they both equal 3. And if you remember from transitive property, it's when two different sides of your equal sign equal the same thing, that means they have to be equal. And that's TRANS just means the transitive property. Let me know if that's still confusing and I can help you with that. But alright, on this next one, let's talk a minute about the notation here. On example 2, if AB, segment AB, see the line above A and B? That means segment AB. When the line's taken away, like for your conclusion here, I'm going to make a little note here. When the segment line is missing, that's a G. When the segment line is missing, this implies length, the actual length. You're going to notice in geometry it'll say something like find AB, and it won't have the segment line over it. It means the distance. I mean, you will be using the distance formulas a lot of times when they're asking you to find the length of a segment, or you might even be adding links together or whatever, but they will give you just the endpoints, and it does mean it's describing length. Make sure you put a line over. I don't know if you can see it, but you do need to write the given statement that AB is your given statement. AB equals AB just means that the length is equal to itself, and that does sound kind of funny, but in geometry you'll use it quite a bit because you will sometimes have shapes that are sharing a segment, and you'll have to use that to prove a more complicated geometry proof. So just remember that when something has the same length, that they're equal, that's the reflexive property. We'll come back to that, I'm sure, but let's move on to example 3. This one has two givens again. 5 times the quantity x plus y equals 45, and x equals 3. If you notice, the semicolon is separating the two givens. And behind the colon that says prove, this is what you're proving. If you notice, y equals 6 is your last statement side, and then the given, the two givens are in the first two rows. So you really are just copying the given, and you are copying what you're proving. Just remember, you can't use prove as your reason. So look down at step 3. These are the first two. On step 3, we substitute the value. In the first step, you substitute the value x equals 3. You replace 3 for x. Then you use the distributive property. 15. 5 times 3 is 15. 5 times y is 5y. Then you move the 15. You subtract 15 on both sides. So that's the subtraction property, results in the 5y equals 30 because you moved the 15 to the other side of the equal sign. And the final step is to solve for y. You're dividing both sides by 5. That's why it's div division property. Alright, let's go to example 4. This one has 1 given, 2 times the quantity 3x plus 4. And again, because of the parenthesis next to the 2, you will use the distributive property. That's going to give you 6x plus 8 equals 44. DIST just means the distributive property. And then you might want to think, how do I move the 8 to the other side? And because it's plus 8, you have to subtract it. And after you subtract 8 from both sides of the equation, you get 6x equals 36. Because 44 minus 8 is 36. That's the subtraction property. And anytime you're left with the multiplication of a number times x, to get rid of it, you divide. So you divide both sides by 6. That's the division property, so x equals 6. These are all kind of similar. You're learning to show how you work a problem using some words. Maybe you've heard these words from a math teacher when they teach you, but now you're having to write the reasons for each step. So it's kind of like you are giving reasons why this works. You're using some math vocabulary. Alright, look at the next one. There's 2 givens. Go ahead and write both of those, and then use the substitution property again to replace your y. Step 1 has a y, step 3 has a 3. That's because on step 2 we know y is 3, so we can replace it. That's called the substitution property, S-U-B-S-T. The reason you need to use ST is because if you just put sub, it may look like subtraction. If you notice, we're using S-U-B-T-R for subtraction property. So S-U-B-S-T means the substitution property. Now the only way to remove the parentheses is to multiply the 3 times the quantity x plus 1, 3 times x and 3 times 1. That's 3x plus 3 equals 51. To change 3x plus 3 equals 51 to just 3x, you have to move the 3, subtract it. Since you're subtracting both sides, the result is 3x equals 48. And then to solve for x, you divide by 3. That's how x equals 16. And the reason you're writing subtraction is because that's how you got this answer. The reason you write x equals 16 is that's how you got this answer. You divided both sides by 3. I hope this makes sense. This might be new, trying to write reasons for your algebra problem. After a while it'll get a little bit better. You'll start learning these properties. So let me know if you need some more help.